Good morning everyone. Welcome to this webinar about Scia Concrete Section. My name is Scia Asselberg and I will be presenting this new product to you together with my colleague Jarda Bros. I'll start by framing the context a bit. So in fact the initial goal of this application was to provide a solution for structural engineers dealing with reinforced concrete structures. A calculation and verification tool to be used in the daily practice. The most important specifications were that the tool needed to be intuitive, easy to use. It needed to have a high performance, which means, for instance, immediate response when adapting input values. Also very important is to have a clear and transparent reporting to assist you in dealing with the requirements of Eurocode 2. So we came up with this new standalone tool that can, for instance, be used for the checking of existing structural members, let's say in the context of renovation work. So there's a screenshot to give you an idea, and this new standalone application is called Scia Concrete Section. And in fact it is up to you if you want to use it for a quick check or rather for a detailed analysis. It's up to the user to define the level, the level of output detail. For instance, for a quick check you can stick to the summary table with an overview of the status of all checks, or you can rather switch to the detailed output where you get a full description of the calculation procedure. Next, I will tell you something about the technology behind Scia Concrete Section. This has been developed within the Scia Design Forms environment. For those of you who have never heard of Scia Design Forms before, this is a new technology platform, in fact a scripting tool dedicated for structural calculations. The outputs of the design forms allows for the display of formulas, text, tables, dynamic images, graphics, etc. So what has been done for the Scia Concrete section? In fact, a set of separate design forms has been implemented, each of them containing a specific check of reinforced concrete sections. So you see them appearing on the screen now. So this is the outputs of the design forms, and these standalone checks have been connected to one master design form where the complete input and output is dealt with. Hence the Scia Concrete section was born. Also important to tell you is that the calculation heart behind the checks is based on our powerful concrete toolbox. This is a set of code-independent functions, in fact generic algorithms, for the design and checking of reinforced concrete members. So these functions can be linked to Scia Design Forms, but also to any other software, and then only the code-dependent parts needed to be hard-coded in the design forms itself. These functions have a very high performance, and because they are generic, they support calculations of arbitrary cross-section shapes, including arbitrary reinforcement positions, and they may be subjected by arbitrary loads. On the next slide, you will find some more info about the current content of the calculation. So you will see that the first version already offers a wide range of checks according to Eurocode 2. For the checks at the ultimate limit states, you will find a capacity check for the interaction of normal force and bending moments, as well as a check of the ultimate stresses and strains, also for this normal force bending moments interaction. And as a third check at ULS, a capacity check for the interaction of shear forces. At the serviceability limit state then, we will find a check for the limitation of the stresses, a check for the crack width limitation, and one for the limitation of deflection. And as I already told you on the previous slides, because the concrete toolbox is at the base of these checks, they are valid for general cross-section shapes and arbitrary reinforcement positions, for a combination of normal force, biaxial bending moments, and biaxial shear forces. Some other highlights then of the Scia Concrete section. I will go over this quite quickly because my colleague Jarda will be showing this to you in the live demonstration immediately. So the level of output detail can be chosen by you. There are dynamic images including interaction diagrams. There is a summary table available at all times with the status of the checks. There's an error warning note system, and of course you can also print and export to several file formats. So you see, the first version is already very powerful, but of course some nice extensions are already under development and are to be expected by you. Currently, the main standard with recommended parameter values is implemented, but extensions for several national annexes are under development and will be released soon. So this will be part of the first batch of Scia Concrete section. Also, additional checks are under development, for instance for the interaction of shear forces and torsion, check of detailing provisions as well. We will also provide design functions, so to design reinforcement according to the ultimate and serviceability limit states. We will extend the cross-section library, for instance to support openings in the sections as well. We will provide support of multiple loading sets per limit state. And last but not least, we also plan to link this currently standalone tool to Scia Engineer. And then now over to Jarda for a live presentation in Scia Concrete section.
Good morning. I would like to present you the live demonstration of our application Scia Design Forms. Let me shortly describe the dialog input and then I will show you some outputs. So on the first step there is a possibility to write some information about the project, some number of project, date, the name of the author, and some short description. You can also see here the national code and also the possibility to select the national annex. As Sonia said, currently there is only one standard national annex for the Eurocode. On the next tab there can be selected material for concrete from the library. If I would like to see some details about material of concrete, not only the name, I can click here and I will see all the information about the concrete which I would like to use it during the calculation. The same thing is valid also for reinforcement. I can select reinforcement from library. This library is based on the Eurocode specification, and at the bottom there is possibility to set informations related to the concrete cover. The tab with selection of cross-section, we have 6 predefined shapes of cross-section. The first one is rectangle, the next one is circle, then T-section, I-section, reversed T-section and also oval. There is also possibility to select general cross-section, and you can type the coordinates of the cross-section. The second tab is related to selection of the longitudinal reinforcement. You can see here some predefined shapes, and if I would like to use my own distribution of the longitudinal reinforcement in the cross-section, I can easily use it via a table with coordinates of the position of reinforcement bar and also bar diameter. The last step is related to stirrup. I can select from two predefined shapes of stirrups. I can also change the bar diameter, spacing between stirrups, and the angle of the stirrup. The next tab is related to load and load set. The first load set is related to ultimate limit states, which is used for the capacity, interaction check, response check, and also a check of biaxial shear. The rest of loading sets is related to serviceability limit states, characteristic, and quasi-permanents, which are used for check for stress limitation, correctivity limitation, and also the check of the deflection. I will prepare some simple project with the T-section, which is loaded by normal force and the bending moment related to y-axis. As Sonia said, we have several layouts. The first layout is a summary layout with the summary of the checks and also some information about the project data. And also here is some information about inputted data related to cross-section and materials, table with longitudinal reinforcement, information about stirrups, and some information about the reinforcement ratio. If I would like to see some detailed information about the particular checks, I can select from the rest of layouts. The first one is called brief. This layout contains only the short table with the unity value of check and also with some explanation of the error warning and notes. The more detailed standard layout, which also consists some pictures, for example, interaction diagram, and the last one is the detailed output, which consists all information about the calculation, all used formulas, pictures, etc. On the tab results, you can also select some information which you would like to display, for example, project data or some picture of cross-section, some information about ratio, and also I can easily go through the checks. When I clicked on the name of the check, I can also select that I wouldn't calculate the check. I can easily uncheck, then the check is not calculated at all. I can switch it back. Now it's only calculated. I would like to see some results. I can check the checkbox text. Now I can see just the pure text, and I would like to see also the images. Now somewhere below or above, yeah, above is the picture of the cross-section with the stress distribution and strain distribution. As Sonia said, we developed this application also for the general cross-section. I prepared the cross-section with the U shape. You can see here the table input for the outline polygon of the cross-section. When I'm on this first row, I can see that it's this point on the picture. When I switch to tab reinforcement, I will see the table for the input of the reinforcement with the coordinates of position of reinforcement bar and also with the diameter of reinforcement. And as you can see here, you can also select if you would like to input all data in millimeters, meters, centimeters, foot, yards. It's up to you. Here you can see the input for the stirrup. I defined 3 stirrups, the first one, second one, and the third one. The technology of the inputting is based on the table where I have to put the coordinates of points which defines the outline of the stirrup, and also I have to use some index for the stirrup, so 0 for the first one, 1 for the second one, and 2 for the rest. So if I go back to the tab results, and if I carefully look on the summary of the checks, I can see that in the case of capacity check for the shear, there is some problem. Here is some marks that okay, but it means that there is some warning. If I switch, for example, to the brief layout, click on the capacity, I will see here the table with warning and also with the proposed solution. When I fulfill this proposed solution, then the results of the check will be okay. I can see here also some notes which shows me that something was done on the background of the calculation. For example, that the value of the angle was iteratively calculated until this condition was fulfilled. The next one, stress limitation is not okay. The unity check is above 1. It doesn't mean that this check is not okay, and I would like to see what is wrong. I can see here in the table that there are 2 errors, which with this description and with this proposed solution. Once again, if I do this proposed solution, I will obtain the check OK. So on the last step, there is some calculation setting related to ultimate limit states, and also for some serviceability limit states like the tensile strength of the concrete and some informations and data which are needed for the calculation of deflection and the stiffness. And I think that it's all from my side. If you have some question or remarks, you can ask via your chat box. All these pictures are dynamic. It means that when I something change in the dialog, it's intermediately changed. So I change this coordinates and the shape of the setup was also changed. Or if I do some modification of the cross-section, not this one, and also the rest of the pictures was redrawn. You can see here also the picture of the check which comes from the check response. I can see here the stress distributions, terrain distribution, and also the part of the compressed concrete. It's the biaxial loading. Here I can see the picture for the shear check with the picture of the cross-section and also the distribution of stirrups along the length of the member. So I think that it's all from my side, and we can go to the question and answers part of our webinar.
Thank you, Jarda, for your nice live demonstration of Scia Concrete Section. Before we go to the questions and answers, I would like to give you some extra information about the upcoming release. So the release of Scia Concrete Section is planned for next Monday, the 9th of December. This means the English version. Currently, translations to Dutch, German, French, Czech and Slovak are ongoing, and they will be available in a next batch soon after. So you have seen in the demonstration that Scia Concrete Section is very intuitive and easy to use. So if you would like to try out it for yourself, you can apply also from next week for a tryout version. So via the link that you see displayed on the screen at the moment. Also, I would like to inform you about a very special offer. There's an early bird price of only 800 euros instead of 1500 euros, which is valid until the end of December. So if you're interested, don't hesitate to contact your local sales representative or email Jarda or me at our email addresses also shown on the screen. And of course, also feedback, proposals, questions are very welcome and can be sent to the same addresses. So during the next week, you will also receive an email with a link to the recorded version of this webinar and also a link to the tryout version. Thank you for your attention, and we hope to see you soon. Bye.